In today's lesson, we will be talking about translations. In this lesson, you will be able to identify translations, and you will be able to translate figures in the coordinate plane. Let's first define what a transformation is before we move on to a translation. A transformation changes a figure into another figure. The new figure is called the image, and you'll often hear that the original figure is called the pre-image. Now, a translation is a transformation in which a figure slides but does not turn. Every point of the figure moves in the same distance and in the same direction. Let's begin by looking at a couple different figures and deciding if it is a translation or not. So first of all, your notes are not in color, so it'd be a good idea either to put them in color or to write maybe an R and a B on each shape. So then you can be able to easily look back at your notes and know, well, which one was the red one and which one was the blue one without having to watch the video again. So remember, a translation is just a movement. And remember, they are congruent figures. And remember, congruent means that they are equal, equal size, equal angles, equal side lengths. Everything about it is equal or congruent. So first of all, when we look at number 1, we should hopefully notice that the figure, that's the red one, is smaller than the blue one. So even though if I took this red one and I slid it over like a translation, it does slide over, but it would be smaller on it. So if I, maybe draw what might be that other red one on top of it, if I were to actually move it over like how we did in our activity on the Chromebooks, it wouldn't fit exactly the same. The red one would be smaller. So no, it is not a translation. Because the figures are not congruent. Go ahead and pause the video and try number 2 and number 3. Answer whether or not the blue figure is a translation of the red figure, and then come back and check your answers. So number 2, if my red figure is moved, it would not be angled the same way. So if I were to again kind of draw what it would be if I just slid it up, it would be angled at a different side. So it's not a translation. There might be a transformation going on, but it's not a translation. Alright, so no, it is not a translation because you cannot slide the figure to the image. Now for number 3, if I take this red image right here and I slid it kind of at an angle or maybe up and then over, it would slide right on top of that blue image. So yes, they are, it is a translation. Because you can move it up and over. Now we're going to actually take some polygons. So remember, polygons we talked about in class are just 3 or more sided figures, and we're going to move them. And the easiest way to move them is about the coordinate grid. That way we can describe our directions and how we are moving this. So the first thing that you want to do is graph the triangle ABC with the vertices A, negative 2, 2, B, 3, 4, and C, 4, 1. Why don't you pause the video and do that? Okay, so here is our triangle. Notice how I labeled each of the vertices. The vertices just mean the corners of the polygon, and I labeled them each. So then that way when I move it, I can easily figure out what my new vertices are and be able to give those new vertices. Our directions tell us to translate it 2 units to the left and 5 units down. So we're going to take that each vertice and we're going to move it. I'm going to start with A and I'm going to go 2 to the left, so 1, 2, and 5 down. So I don't make a point until I do both directions. So 1, 2, 3, 4, 5, and my new vertice is going to go right there. So I have my new value right here, and I'm going to call it A with an apostrophe. It's called A prime. And I'm going to give my new value, which is now negative 4, negative 3. Now we're going to go back through and we're going to do the same thing with each of our other vertices. So we're going to take that B and we're going to move it over to the left 2 and down 5. And there's my new B, or my B prime. So my new B prime is positive 1, negative 1. And then lastly, C is going to move over to the left 2 and down 5, and it'll go right there. So again, I'm going to label it C prime, my new value being 2, negative 4. And I will connect those and make my image. So the whole image has now been moved to the left 2 and down 5. Moving on to number 2, now we have a rectangle. It's going to be the same idea, we just have more vertices to move. So why don't you pause the video and draw the rectangle. If you feel confident, go ahead and translate the figure 3 units to the left and 4 units down, and write the coordinates of the vertices. Here is our pre-image. Now we're going to draw the make a translation of 3 units to the left and 4 units down. So again, we'll take each of the vertices and we'll go 3 left, so 1, 2, 3, and 4 down. 1, 2, 3, 4. And my new A is going to be right on the x-axis there. So my A prime will be negative 2, 0. And then now you want to go through and do that for all of the values. So again, all of the vertices, I'm sorry. So again, I'm going to take the B, I'm going to move it over 1, 2, 3, and down 1, 2, 3, 4. Now my new B is at the origin, 0, 0. And I'm going to take C, move it over 3, and move it down 4. And there's my C prime. Zero, negative 3. And then lastly, I'm going to take my A, move it over 3 and down 4. Sorry, my D. And so my new D prime is negative 2, negative 3. You have one more triangle to move. This time we're going to move it 2 units to the left again, but this time 5 units up. So why don't you go from the beginning to end with this one, and see if you can figure out a way as you're doing this to do this problem without graphing it. So kind of challenge yourself as you're doing this to come up with the A prime, B prime, and C prime before you actually take the graph and you move it. Alright, so here is the image. I did the pre-image in black for you to see, and then the image in blue. So I took, again, each of the vertices, we moved it to the left 2 and up 5 there. So from the graph, I can see that new point is negative 5, positive 7, or I could start looking at, okay, I'm moving this value, it was at negative 3, and I moved it to the left 2 units. My new answer is negative 5. What could I do to figure out that new value without graphing it? And if you said go negative 3 minus 2, that would be correct, because I'm going left, so that would mean that I would minus 2. Now, since I'm going 5 units up, I can take that number 2, where it was at, and add 5 to it in order to get the 7, which if you look over in your graph, it is definitely up 7 in that point. So this would be a way that we can, now I can do the same thing for the other vertices as well. So I started off with 2, 2. If I take that x value of 2 and I take it to the left, I would be subtracting 2. So I'd be going 2 minus 2 is 0. And then my y value of 2, I would add 5 to it to get 7. Again, I can double check my graph. Sure enough, that's exactly where it is at 0, 7. Again, with c, I'm going to subtract 2. So 2 minus 2 gives me my new x value of 0. And then negative 3 plus 5 gives me my new y value of 2. So when we are doing these, we can either physically move the graph the direction that we need, or we can take the original or the pre-image vertices and we can add or subtract. So when I add or subtract to the x, that is going to move it horizontally. And if I'm adding, it moves to the right. If I'm subtracting, it moves to the left. And then for my y value, that is going to be a vertical movement. And if I'm adding, it moves it up. If I'm subtracting, it moves it down. Don't forget to do your summarize. So summarize on how to tell if a figure is a translation of an original image and how to translate that figure on the coordinate grid. Your question today will again be a problem where you need to try on your own. And so you have two problems actually here, the arrows, and then you also have the lightning bolts. Is the red figure a translation of the blue? Again, this would be a good idea to write the R and the B on there so then you can look at it later and know what it's asking. Don't forget to explain.